Good morning, children. Today we will talk about taking infinite limits, which doesn't mean we're going to do infinity of them. It means go to infinity or the infinite. So here we go to get started. Remember, please take notes with me so that you have reasons to use for your weekly homework or for quizzes or tests that come. So here's the first question I want to talk about. And we're going to do what we've always done. Step one for a limit is always plug in. So you might be upset about this floating here, but don't be. It just means we're plugging in a number that's a little bit less than 2. So I know there was a time in your life where you would say a number a little bit less than 2, like 1.99. I'm fairly sure you did this at some point. And so I'm going to write it so that you're comfortable, but then I'm never doing this again. So a number a little bit less than 2, I'm going to plug in. Well, if it were 2, I would have 2 squared is 4, minus 4 times 2 is 8. That's a negative 4 on top. So plug it in. And then on bottom is where things get interesting. So I already know that this is not going to be an indeterminate form because indeterminates for you right now are only 0 over 0. And I have a negative 4 over 0. On bottom, you know it's a 0. I know it's a 0. Minus 2. Now we have to talk about what kind of 0 it is. So if it's a number a little bit less than 2 minus an actual 2, then that's going to be negative 4 over a number a little bit less than 0. So it's a really, 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 really tiny but negative number. So a number, a constant divided by 0 equals infinity. I know you want to say undefined, and that's true in terms of graphing. It makes an undefined value, which is a vertical asymptote, and we'll get there. But if you're dividing a constant by a 0, you get infinity. This one's a positive infinity because a negative divided by a negative is positive. So let's do the same question, but we're going to come at it from the right. So 2 on the right. We're going to do the exact same thing. Step 1, plug in. So if I go plug in, I'm not doing this again. I refuse. It hurts so much. I hate it. But if I go plug in a 2, 2 squared is 4, minus 8 makes a negative 4, so that I know I'm not dealing with an indeterminate. And then I have 2 minus 2, which is a 0, but let's talk about what kind of 0. So I have negative 4 over a number a little bit bigger than 2, like a 2.1, minus an actual 2 is going to leave us with a small but positive 0. This time, when I divide, I'm going to get infinity, but this one's going to be negative infinity because a negative by a positive is a negative. And that is infinite limits, essentially. So both of these together, if I then asked a follow-up question, or if I started with this question, you would have to know. I'm going to do the exact same function in here. But you would have to know if I just go to approach 2, not from the left or from the right, you'd have to know to do both. And then you would say here does not exist because your left and right don't match. Your left limit was infinity, your right limit was negative infinity, and those are not the same thing. So you say it does not exist. All right, that's one way we can deal with infinite limits, is when you get an answer of infinity. Here are others. I hope that these next 3 questions you have seen before. Questions, the way we do questions. So I'm going to work them out the long way for the first time. Talk about shortcuts. So this time the limit is actually going to infinity, which is another way to call an infinite limit. I think when you talked to Pickle about these last year, I think you guys sat there and you divided by 1 over x, and or you multiplied by 1 over x, 1 over x. You divided x out of top and bottom, which is completely legal as long as you do it everywhere. So now as we go to infinity, you're distributing this in. I'd have 1 over x minus 2 over x plus 1 over x. And then as I go investigate what's going on, if we're going to infinity, 1 over infinity goes to 0. So does this one. And now I'm left with a negative 2 over a super huge infinity number. 2 divided by big, anything divided by big is going to 0. Your book sometimes plus minus here. That's not important. If it's positive 0 or negative 0, because 0 doesn't actually have a sign. We're not going to try that. All right, that's one. Let's try this one. We're going to go to infinity for this thing. We're going to do it the same way. So we're going to go divide top and bottom by the biggest power. Not power. I usually use the biggest power in the numerator. So I'm going to divide top and bottom by whatever. I don't mean divide. Really. All right, I'm going to multiply top and bottom by 1 over x squared. I'm going to distribute it into every single term, and then I'm going to see what's happening. So if I distribute in, now I have 1 over x squared plus 2 over x plus 1. And then on bottom, I have 4 plus 1 over x squared. And the reason you're doing this is because these are really easy to see. 1 over really huge, going to 0. 2 over really huge, going to 0. Same thing down here. And you're just left with a 4. And that's not so bad. Last one. I hope this is familiar. If you need to like fast forward through, it won't hurt my feelings. But if you also want to pause after I get this one written and give it a shot, I'm going to do it the same way I did 4 and 5. So if you want to pause, go ahead and divide top and bottom by the same power and see what happens. But I'm going to keep working because I don't know if I'm going to divide square top and bottom. I'm going to carefully distribute it in, and that would be 1 over x squared, a 1 over x, and a squared. Okay, this one's a little bit different. Maybe this is going to 0. Uh-oh. This is going to 0. This is going to 0. It's not indeterminate. It's not indeterminate because the top is 1 and the bottom is 0. And now all we have to do is figure out what kind of 0 it is. I know this answer is going to be infinity. I just have to figure out if it's positive infinity or negative infinity. And that's determined by what kind of 0 this is. So this 0, this 1 over infinity is positive. This 1 over infinity is positive because it's squared for sure. So if that's a positive 0, that's a positive infinity. Positive, positive, positive. Great. Let's talk about the shortcuts here. So you are only allowed to do these. I'm going to write it real big. This is only for x is approaching an infinity, either one. And it's only for if you have polynomials in your numerator and denominator. So this will not work for exponentials or your absolute value functions or any of those. And again, only for x is going to infinity. So only for infinite limits. Here are your shortcuts. If the top degree, the degree on top is less than the degree on bottom, it's a G. You will go to 0 every time. And that's like number 4. So the top degree was 1. The bottom degree was 2. 1 is less than 2, so this is going to 0. If the degree on top is equal to the degree on bottom, then you take the ratio of your leading coefficients. And you need to be careful with this one. I like to make things up. Show you the word coefficients. So in number 5, we did 5, the degree on top was 2. The degree on bottom was 2. Those are the same number, but notice I didn't write this top polynomial in standard form in order. It's got a coefficient here of 1, a coefficient here of 4, and that's how I got 1/4 of my answer. And then the last case is if your degree on top is greater than your degree on bottom. And in that situation, you will go to an infinity every time. You might have to do a little bit of work to figure out what kind of infinity it is, but it's usually not full question that you have to work. So over again, degree here is 2, degree here is 1, 2 is bigger than 1, so we went to infinity. If you encounter any of these questions, so any of these questions, if they pop up and you have degrees and you're going to infinity and they're polynomials, you are welcome and you are encouraged to jump straight to the answer. I highly recommend it. If you can't, if you forget, if your mind goes blank and you need to go divide out powers, it's fine, it works. But if we're dealing in a timed test or quiz situation, jumping to an answer is completely legitimate. And you don't even have to say, using the shortcuts that Mrs. Williams talked about in her video. No, just do it, and everybody knows, and it's fine. Okay. Last couple of things here. I want to review all of your indeterminate forms. I think I did this with the fourth of you one day, but for the rest of you, let's get them down. So you already know 0 over 0, and that one you've been using regularly. Now, starting today, you're going to have infinity over infinity because your limits are going to be going to infinity. That's your next indeterminate form. The other one that's going to be pretty important to you in a second is this guy, but I'm going to list all of them so that you have them because we're going to call on them over and over. The hardest part about indeterminate forms is knowing when you have one and not thinking that you're done, because indeterminate means keep looking. So if you encounter like a 1 to the infinity and you think that just equals 1 and you don't even know to keep looking, that's a problem. We're going to write them a lot. We're going to write them regularly. We'll talk about them as much as we can. All right, we're going to work on more limit. This is kind of a challenge limit for you. I'm going to write it. I'm going to get started. And I really would like for you to pause and see what you can do. So here it is. X squared plus 4x minus x. All right, I'm going to get you started, so don't pause yet. If we were to step 1 plug in, which I didn't do for 4, 5, and 6 up there, but you should always step 1 plug in, I would have infinity squared, square rooted, that's fine, still infinity, still really big, minus infinity. Oh, look, that's indeterminate. Okay, no problem, keep looking. So you keep looking options. Remember, next you're going to go to algebra. Your algebra options are factor, conjugate, common denominator, sometimes expansion works. The only thing that's going to help you here is a conjugate, because you've got this radical. And so we can make that go away at least. That will be helpful. Remember to do it top and bottom, even though there is no bottom, you've made one. All right, I'd like for you to pause, work it out, see what happens. So I'm going to take a 5-second breath. Okay, I hope you worked. Now let's see. So I got a limit going to infinity. When I distribute on top, I get x squared plus 4x minus x squared, which is always good news when things go away. Things don't go away when you do that. Conjugate multiplication, you should probably go check your signs. So there we go. Goodbye x squareds, and life is already better. Here's what I think you did, because Pickle has trained you so well. I think you went and multiplied by 1 over x, 1 over x, or divided by x, depending on how you like to write it. It doesn't matter. That's what I think you did. I might be wrong. I'll never know. It's a video. But that leaves you with 4 on top. That makes it messy under here. So here's what I'm going to do. When I go divide the square root of x squared 4x, I'm going to say multiply. When I multiply by 1 over x, what I'm going to do is I'm going to treat it like multiplying by 1 over the square root of x squared. These are the same thing. We all know, of course, we all know that. These are the same thing. But that way I can put everything in the radical together. And that make it easier to clean. So I'm going to square root the whole thing. X squared over x squared is 1. 4x over x squared is 4 over x. And then don't lose this sign in the end, it's just 1. Then you're finished, because 4 over x is going to infinity, this is going to 0. I have 4 on top. I have root 1 plus 1 is 2. Final answer is 2. That's what I think you did. There's nothing wrong with it. Full credit, 100%. So proud of you. But if you are paying really close attention and catching up or catching on to these shortcuts quickly, you can be done right here with no extra work. Just check out your degrees. This guy on top has a degree of 1. This guy on bottom also has a degree of 1. I know it's weird. I know it's weird. I know it's weird. There's a 1 here. This guy is essentially raised to half, but this guy is raised to the 1, right? It's a squared square rooted. So your common degree is 1. They have the same degree, top to bottom. Then when you look at coefficients, coefficient on top is 4. That's not so hard to see. Coefficient on bottom, there would be a root 1 here plus this one here makes 2. I know that probably hurts a little bit because what I just did to you is what you should never do. I just told you this, but I didn't really. I wasn't separating them out. We were just talking in generals. If we're out at infinity, the only thing I really care about is what's got the biggest power, because I'm at infinity. So only the things with the biggest powers are going to be the biggest players. All right. That's all I've got for you for infinite limits. Tomorrow we'll talk about how these infinite limits play into asymptotes, which a lot of that you already know too. So that should be a good day. Bye, kids. Let me know if you need questions and help.